Thank you. Thank you for taking your seats. We're about to start. Okay. I get the sign that we're all here. Thank you very much for coming back after your coffee break. I could see everyone had a good time chatting toward each other. Before I give the floor to our next moderator, Professor Marita from Kenya, I would like to ask the students who are here in the audience, could you please quickly raise your hands? Okay, the ones who did not raise, thank you. Okay, because of you, we could allow so many students to come today because we were waiving their fees because of the generous support by Enel, but also because you paid for your registration to allow the students to come and enjoy and learn from each other. So thank you for that, and I hope that we all get to meet you, as in the students as well, to speak and understand how you going to drive the acceleration curve for geothermal, because you are the next generation who is going to do it. I'm going to hand over, but one question I have for you is that when we break for lunch, it is 1 o'clock, and before we get to lunch, we're going to do a group picture. And we're going to do that very close. It's on the staircase if we go out of the door towards the left. And we have the photographer who is then going to make a couple of wonderful slides of our group here today. So before we get to eat lunch, I would really like to ask you to join on the staircase, and I'm sure we will be guided in the right direction to get everyone on it, because we are with 150 people here today, which is a magnificent result. I'm now thank you. I'm handing over for session 2 on the perspectives, outlook, and the history of geothermal energy to Professor Marita. I am extremely honored to have a Kenyan delegation on site. UGI and UNIDO both did an excellent job of getting 4 representatives of Kenya here today as well to join in, engage, and network between our continents. Prof. Marita, it is your turn, it is your stage, and thank you very much for coming over. Thank you.
Thank you so much, Marit, for that introduction. Yes, I'm happy to be here, and I would like to express my appreciation to UNIDO, ANL, and whoever contributed to our coming here. We're very happy to be here and be here for the next 4 or 5 days, which is really very nice. So without further ado, I will ask my presenters to come to the front, if they can, please. There are 3 of them. That is Carlo, Doglioni, and Bruno, Della, and Monia. Sorry about my pronunciation. If they can come to the front. And as they prepare to come to the front, Carlo is on to present on the geodynamic origin of the geothermal gradient and induced seismicity. And then the second presenter, Bruno, will talk about the Italian and European geothermal status as we have it now. Then finally, there will be the talk by Monia on geothermal potential in Italy and the focus on the Eolian islands. So again, as the previous block, we'll take 15 minutes presentations, one after the other. And then after the 2 presentations, we'll take about 45 minutes or so. We shall then invite Q&A, question and answers or comments. Please feel free that time. So I have the honor, and please, as you come to the front, do introduce yourself. I don't have your profile, so tell us about who you are in 1 or 2 minutes, and then proceed on. So let us start with Carlo, please.
Good morning, everybody. Well, we receive between 44 terawatts from the mantle, from the earth interior. And So this heat is released by oceanic ridges, subduction zones everywhere. We have this dissipation of heat from the mantle. But we know that the interior of the Earth is stratified, and we have this strong anisotropy between 100 and 150 kilometers depth, which is the low velocity zone, where we infer that at the base of the lithosphere, the temperature is around 1300 degrees, which is the melting temperature of the mantle. So that's the reason why we have this low velocity zone, where we infer that the geotherm is slightly to the right of the mantle solidus, providing some melting material which is uprising along volcanic zones, but also contributes to store the heat coming from the mantle. So we have different geotherms all over the world as a function of the tectonic setting, the geodynamic setting. We have cold areas like obviously the area to the left where we see these you see the cold geotherm with a geotherm which is decreasing in deep going down, where in the mantle the temperature increases less than 1 degree per kilometer. Whereas in hot geothermal areas we have a much hotter initial gradient, which is also decreasing very quickly when the temperature, we measure the temperature within the low velocity zone and down into the lower part of the upper mantle. So along oceanic ridges, we have the areas where the low velocity zone is closer to the surface. So we have the highest thermal gradient. In fact, here in Iceland, for example, you see clearly the high thermal gradient, which is regionally even higher than 200, 250 milliwatt. So in Italy, we have a special situation in which the country is shaped by two subduction zones, one in which the European plate is subducting beneath the Adriatic plate, and the second subduction zone where the Adriatic plate is subducting westward beneath the European plate. So you can realize immediately that in the Alps there is no back-arc basin, whereas in the Apennines we do have a back-arc basin. So the Bouguer anomaly in Italy gives us a good indication of the mantle dislocation. You see the Tyrrhenian Sea, where the mantle is clearly very high, like in the Biscay Basin, the Provençal Basin, whereas beneath the Alps, the mantle is much deeper. So when we make two geological cross-sections, we see that the Alps are very different from the Apennines. And when we want to check to find the lithospheric, astenospheric transition, we have to go down to 100 kilometers depth, whereas in the Apennines, we have the astenosphere transition, which may be under our feet here at 30, 40 kilometers depth. So a much hotter mantle in the Apenninic subduction zone. So the two subduction zones are very different. The orogens are very different. You see large outcrops of basement rocks in the Alps, double verging, and so on. Whereas in the Apennines, we have a accretionary wedge which is mostly made by sedimentary cover, apart from the relics of the alpine orogen in the hanging wall. So we have two types of systems in which the one to the left, you recognize that the mantle is much shallower, so the temperature is much higher in the hanging wall, in the back-arc basin, whereas in the other subduction zones, the astenosphere, which with his temperature is much deeper. So we have hot and cold geotherms as a function of the tectonic setting. And the data from Bruno Della Vedova and co-workers, we clearly see that in the Apennines, the thermal gradient and the heat flow is much higher, especially in the hanging wall of the subduction zones, whereas in the Alps is much lower. So in the Apennines, we have a subduction which retreated during time up to the present position, and generating the migration of the subduction hinge up to the present situation, in which we have the Adriatic plate, which is subducting westward, and most of the seismicity, which is concentrated partly in the subducting slab and mostly in the hanging wall plate where we are now. So the slab is retreating from the left to the right, and you see these gray dots which are moving horizontally. So the mantle is migrating eastward relative to the overlying lithosphere, and so the heat itself is also migrating eastward. Up to the present situation, so we have the highest heat flow in the Tyrrhenian Basin and in the west coast, west part of the Apenninic corrosion. So the system is migrating, and the migration of the back arc allows the migration of the heat released by the mantle. So we have this slab which is subducted. You have to imagine this slab that was originally horizontal. So that star once was at the surface, so it was accreted in the accretionary prism. So the original maw of that red star is now subducted into the mantle, but now is lying on top of a shallow new mantle. So we have a new maw, a new actually lithosphere-asthenosphere boundary, practically losing the lithospheric mantle in between. So we have a much higher temperature in the hanging wall of the subduction with respect to the footwall. So you see the 1300 degrees, which is much shallower in the hanging wall of the subduction with respect to the base of the lithosphere, for example, in the Adriatic. This is the same situation in, if you want, in the Caribbean, in the Carpathians, or all the west-directed subduction zones. So the key issue is that we have a very shallow asthenosphere with higher temperature just in the hinge of the subduction zone. So also the geothermals are very different, whether we are in the footwall plate or in the hanging wall plate, and the maw temperature is also very different from, let's say, a classical foreland maw temperature of about 500 degrees. We may have a temperature at the maw which may rise to 800 or 900 degrees, and especially we may calculate the temperature at the maw using shear wave velocities, for example. And you see, for example, here that the maw temperature in the hanging wall is much higher than the maw temperature in the footwall. So you see in Tuscany, on lower Tyrrhenian Sea, we see the temperature and the thermal gradient which are much higher with respect to the foreland plate. So in a cross-section, very simplified, we have a thermal anomaly with the milliwatt expression that you see clearly demonstrating the uprise of the mantle. But here in Larderello, like in all other volcanic areas of Italy, we have a spike which is related to the thermal and material which is transported upward by the mantle with values of milliwatt which may overtake also 1000. So these spikes are associated to the volcanic expression. We have in Italy about 10 active volcanoes, so Italy is a wonderful country where to project, program, and foster geothermal energy, because here the blue triangle on top is the Amiata volcano and the subvolcano which is underneath our feet here. So, you know, this was the pyroclastic flow of 2 days ago in Stromboli, so volcanic areas, volcanoes are very active in our country. So one of the reasons why geothermal energy is mostly concentrated here in Larderello, unfortunately, is because many regional or local communities are against geothermal energy. Why? Because they think that geothermal energy can generate earthquakes. Well, we know that the disposal of fluids in the underground may generate earthquakes. These authors have shown the connection between disposal of waste fluids in '68. You see this paper, and there are several examples of world-induced seismicity everywhere in the world, especially in the US, where the number of earthquakes rise during the last 20 years, especially because of wastewater disposal into oil wells. So you clearly see that the number of earthquakes in the US increased after 2008 in particular, especially in the mid countries. So with a number of different types of tectonic of energy projects. Well, so I think it may be useful to have an idea of what could be the induced seismicity, to classify it, in order to explain why geothermal energy can be achieved without any problem in terms of induced seismicity. We have the lithostatic load, we have the hydrostatic variation of pressure with depth, and clearly we can show that there are different types of induced seismicity. One, for example, is where we decrease the hydrostatic pressure. And for example, this could be the Groningen gas field, where there was an increase during time of the gas production and increase of earthquakes, and with a magnitude usually between 1.5, very rare events which reached 4. And the reason of this seismicity is related to the depletion of the red sandstones at about 3 kilometers depth. So the removal of fluids in this layer generated a compaction of this layer, so a collapse, gravitational collapse of the overlying volumes, generating small earthquakes. So we call graviquakes because are generated by gravity. So we can calculate the maximum volumes that can be offset and displaced during this type of seismicity, which are relatively small, so generally no more than 4 magnitude 4 can be expected. So in this case, we have the fluid removal, and the critical failure is simply displaced closer to the differential stress, triggering the earthquake. So Haley and Raleigh demonstrated that just removing the fluid injection, the seismicity ceased. So it's well known that this type of seismicity is concentrated during the time of fluids injection. And we see several cases in the US, but also here in Europe. The Basel earthquake 3.6 was related to an increase of pore pressure stronger, bigger than the natural pressure of the deposit. So the reservoir, you see, usually generate a sort of cloud at the bottom of the wells, and we have a decrease in pore pressure, in increased pore pressure that shift to the left the differential stress, generating the seismicity. McGurk has shown that there is a relationship between the amount of volume of water which is injected. So the larger the volumes, the bigger the earthquake that can be generated. So this is the case of number 2, in which we have an increase of the hydrostatic pressure. So the fluid over pressure generate the activity in the subsoil. We have heard before the fracking, which is a case in which the hydrostatic pressure becomes even bigger than the lithostatic. So this is a phenomenon which is well known also in nature, because during an earthquake, fluids are squeezed and they break rocks, penetrating, generating veins of quartz, calcite, or whatever. So we have a situation in which you see the hydrostatic pressure is even bigger than lithostatic pressure. So you clearly see the increase of the differential stress that touches the critical failure envelope. So another case is when we change the volumes which are above the crust, above an active fault, an increase or decrease of loading, which generate either normal faulting or thrust faulting as a function of whether we increase the load or decrease the load, in generating two different settings, because the lithostatic load clearly acts differently as a function of whether we are in extensional setting or in a compressional setting. So we have 4 different cases. This one, for example, several lakes, artificial lakes, have shown seismicity associated to the water loading, which varies the differential stress. So we have 4 different types, especially the one in which pore pressure is increased is the one which interests geothermal exploitation. So we have the gas or oil removal generating compaction of the voids, like the Groningen case, or wastewater injection, where the fluid pressure is higher than the natural reservoir, providing friction reduction in volumes and fault planes, or hydrofracturing seismicity induced by AGS, for example, AGS, or fluid extraction or fluid injection, providing the variations in the hydrostatic pressure and the lithostatic load. I think to have a clear information of what is induced seismicity may help to convey the message that the geothermal energy can be done without any problem for seismicity. Thank you.
Thank you, Carlo, for that good presentation. And now I would like to invite our second speaker, that is Dr. Bruno. You can come. You will be talking on, presenting on Italy's and Europe's geothermal status as we know it currently. Bruno, please.
Thank you. Thank you for introducing me, Dr. Marita. Thanks to IGA and to Enel Green Power for organizing this nice workshop on accelerating geothermal, and thanks to all of you to be here today. I'd like to start stressing the pillars and the key points relying on and being at the base of the acceleration we would like to start and to strengthen back again. Accelerating geothermal needs proudness, needs ambition, but besides needs a little bit of investment. Geothermal is a constant production, ensuring continuity and stability of the reliability of the network and the high operativity. Combined heat and power production has higher efficiency, higher energy saving, less environmental impact. Besides, we should consider the large market for heating and cooling. The geothermal heat pumps have a significant energy saving and are more efficient. The know-how and technology and the production chain for geothermal is available to untap the resource now. We don't need to wait for that, mainly for heating and cooling and district heating and space heating. Another important pillar is that the geothermal energy among all the renewables has the large potential for fast and further improvement of technology efficiency. But we need investment for that. This is just a comparison among the renewables. comparing what's the average weighted capacity factor based on 2018 data from ARENA. Geothermal has by far the highest capacity factor, higher than bioenergy, and of course, higher than all the other renewables. So it's a good candidate to support energy transition and to support a secure energy supply for every country, and we need to start supporting, investing, and putting the stakeholders together to relaunch this important sector of the energy transition. The REU Power actions are based on saving, diversifying, accelerating clear energy, and investment. And geothermal is included in this. Member states should point on district heating systems, energy communities, which is another important enabler in the transition process. And also, we should start focusing and harvesting energy under our feet to support and to use industrial heat whenever available and possible. And we are here for that. Among the 10 top geothermal countries, 3 are from Europe. We have, of course, Turkey, Italy, and Iceland. And Kenya is also, and we are happy that our colleagues are with us today. A quick overview in Europe as far as the main key figures. 142 geothermal electricity plants, 6 new plants in 2021, which is a good sign, a good starting point. 3.5 gigawatt electric installed. District heating is benefiting of a quite significant relaunch in 2021, and we'll see it in a couple of slides. And geothermal heat pumps are an important tool to have geothermal distributed across densely populated areas, cities, and also private houses. Looking at the vertical bars, we have electric production in blue, and in red we have the district heating and cooling figures. Looking at specifically at the electric production, we see that in 2021 we have 6 new plants, 4 in Turkey and 2 in Germany. Looking at I would say, the overall figures of production in selected countries, we see that Turkey is the top one with something as 1,600 megawatts capacity installed. Then there is Italy, then there is Iceland. And looking at I would say, development and plans for the coming years, we see that in the gray bars, there is quite a margin of improvement for 2021 and the future years. If we look at district heating, we see that the new commission plans in Italy, if we look at the round figure on the left on top, we see that there are quite a few. There are 3 in France, 3 in Netherlands, and 1 in all the other countries that you could see there. And after a peak of district heating systems installment in the years 2013, 14, and 16, we are suffering a decrease of new plants installed with I would say, an interesting restart in 2022. That's a good sign, of course, supported by the changing conditions not only in the market. Geothermal heat pumps have also an increase as far as the comparison between 2020 and 2021. You could see substantial percentage increases in Germany, in Sweden, and in the other countries, with peak of percentage increase up to 60–70%. In the lower part of the figure, you could see the stocks of geothermal heat pumps installed, where Sweden has more than 600,000 and all the other countries with smaller numbers of installation. Italy is not included in here. And of course, we have large margins on improvement, and we'll see in a couple of slides. This figure is taken from, of course, the geothermal market report of EGEC, and you could see the reservoirs around Europe upon which we could develop district heating systems. Of course, there are areas not explored and studied yet, and there are other reservoirs not included in this map, but this shows where the main already realized plants are relying on. Looking at the Italian potential, it was already mentioned several times by the previous speakers that we have a huge potential on the Tyrrhenian side of our peninsula, but we have a good potential also in the other part of the country. In the white areas you see on the heat flow map, it does not mean there is no heat flow. That is a low heat flow area induced by the shallow processes, mainly surface water infiltration, which is depressing the heat flow coming from below. But geothermal gradients on the Tyrrhenian side could be as high as 100 or 200 degrees per kilometer. If we look at the electric energy share of Italy, you see a bunch of curves from 1979 to 2020, and you see the energy peak in 2007 up to 360 terawatt hour, and that is coming down now to about 300 terawatt hour, and you see how that energy demand is being supported by. Of course, you see the import from abroad, which is the difference between the two upper curves. You see an increase in gas uses, in the last year, and one important thing you see an important increase from 2007 to 2014 of the renewables, and then you see a flat. That means that there was a lack of growth of about 70 terawatt hour in the last 4 years. So it was a stagnant market without growth. That's a place to point at in terms of relaunching geothermal and the other renewables to fill it up that gap. Because of that, the lack of growth in the last years, more than a decade, I would say, UGI, together with the Italian Association for District Heating Systems, we stimulated the formation and the constitutional working table on geothermal. You see that several operators were included in this, and that because we need to cooperate, we need to create a critical mass in terms of being able to start the support from the institutions, from ministries, the inclusion of local administration, the support of professionals and investors. It was already shown by Adele Manzella what's the realization that could be reached in a few years. By 2030, 240 more megawatts could be installed, including another extra 120 megawatts by 2035. That could contribute with about 3% with respect to the objective that our government set up of about 70 gigawatt capacity from the renewable energy sources. 3% is not a huge contribution, but in that short period of time is a significant contribution that needs to be increased because the potential is still large. Barriers I've also already mentioned, so I will go quickly on this. High upfront cost, we need to reduce the risk, we need investment, we need to accelerate the processes for permits and concessions. And that is a huge obstacle, non-technical barrier, still, I would say, making our production chain suffering. And also, we are waiting for these renewable energy incentives that are still on the ministry tables, and we are waiting for those incentives in order to have our sector to accelerate back again. District heating. District heating has a large potential in the Po Plain, in several other areas around the country where we have rocks with aquifers at I would say accessible depths of 1 or 2 kilometers with temperatures extremely interesting for heating and cooling. With respect to what's supplied now in terms of district heating, we are talking about 9 terawatt-hour of heat provided to the customers. We could do at least 4 times as much in few years' time. And that is another aspect where we should invest in terms of cooperation, in terms of involving institutions. Also, the investors, the operators are, I would say, ready to start on this. But the non-technical barriers are, I would say, reducing the speed of this potential recovery. Just a quick image of a comparison between wind and geothermal, comparing performance on the y-axis with the cumulative research and development investment. What does it mean? It does mean that geothermal is a young technology, not much investment so far. That is a study which has been published by Stern School of Business in 2009, but it's still okay and good. What does it show? It shows that geothermal is in its early stage. If we want geothermal to jump to a new second stage technology, then we need investment. The potential is there. That's my I would say last slide. Thermal gradients we have seen. There's a huge potential. Under our feet, and we need to watch carefully where we walk because the engine is there. Thank you.
Thank you, Bruno, for keeping time. I appreciate that. It was a very good presentation. And I hope members, participants have gotten something from it. But I will ask more or comment more questions after the next speaker, who's going to talk to us on the geothermal potential in Italy and focus on the Eolian Islands. Monia, please welcome.
Good morning, everyone, and It's a pleasure for me to be here, and thanks for the invitation. I briefly introduce myself. I'm a researcher at the INGV, the National Institute of Geophysics and Volcanology. I'm geologist, and in particular, I'm geochemist, and my focus activity is on fluid geochemistry applied to geothermal resource characterization. And in this presentation, I try to speak after two big professors on geothermal potential in Italy in the first part of presentation, and then I give you a focus on Eolian islands, the small minor islands in Sicily. So I would like to start from a global view. And this is the global distribution of the geothermal power plants, the black squares, and the distribution of the Holocene volcanoes and geological CO2 emission. And it's nice to note that the good correlation, spatial correlation among geothermal power plants, volcanoes, and geological CO2 emission. And maybe it's not a case also the image used in the bar of this workshop. And the same situation focusing in Italy, we have also in Italy. This is the map of the heat flux, and the black squares are the geothermal power plants, unfortunately only in Tuscany, and are located, these geothermal plants, close to CO2 geological emission and volcanoes. The colored triangles are the volcanoes along mainly the Mediterranean margin. And the fissure of the Tuscanian area, Tuscanian geothermal area, are also present in other sectors of Italy, mainly along the Mediterranean region. And the age of this volcanism is decreased from north to south. We have age from millions of years in north and present time in south, passing through the Roman magmatic province, where we see the yellow triangles, where the last eruption was 1,000 years ago. The highest deep temperature are related to extensional areas in back arc of the Apennine subduction. We can see the light blue areas in that image. And this sector is also characterized by a considerable thinning of the crust, minor than 26 kilometers. And this sector favors the rising of magma in the upper part of the crust. And this magma in the upper part of the crust, at relatively shallow depth, 3-6 kilometers, are the main heat source that drive the geothermal fissure of the Mediterranean margin, not only in Tuscany, but also in other areas. And the Tuscan geothermal systems, we can see this cross-section from southwest to northeast. We have seen this image before in the presentation of Professor Carlo Doglioni. The Tuscan geothermal systems are related to thinned crust, where we see these green triangles in the cross-section, more or less, are related to thinned crust and presence of shallow magma bodies. And with respect to the Amiata field in the Larderello Travale area, is characterized by non-volcanic outcrops, but many granitic intrusions. And these areas are characterized by many geothermal manifestations, superficial geothermal manifestation, the gassing structure, thermal springs, bubbling pools, and fumaroles. And we have a lot of other areas in Italy, especially where we see the volcanoes with similar fissure. Here we show typical geothermal manifestation. These are the fumaroles in Biancane Park, the thermal spring of San Filippo close to Amiata. In Latium region, we have, for example, bubbling pools and diffused gassing structure, fumaroles field in Campi Flegrei in the Campania region, and fumaroles field in Volcano Islands in the Eolian arc. During 50s, 80s, a geothermal exploration program was performed in Italy, and between 80s, 90s was developed an inventory of geothermal resource. In 2010, more or less, this geothermal inventory developed by Eni, Enel, and CNR and Enea got in this modern dress. The red colors represent the heat flux values. The highest values are present in Tuscany and in the southern part of the Tyrrhenian Sea. The gray cross represents the geothermal wells, and the yellow cross, the geothermal manifestation. The geothermal wells were drilled mainly in Tuscany and in Latium region, in the northern part of the Latium region, in the northern province of Rome and in Viterbo. And some wells were drilled in Campania, close to Campi Flegrei, and in Sicily in two islands, Vulcano and Pantelleria. Nevertheless, the interesting deep temperature, the geothermal development was hindered by logistic or environmental problems and unfavorable characteristic of the reservoir, unfavorable obviously for that area. Then dedicated scientific projects have been carried out to estimate the geothermal potential of Italy. An example is the Atlante Geotermico project led by CNR, by Adele Manzella. And then this is the web page of the project with a favorability geothermal map of southern Italy. And then additional detailed study has permitted to identify additional favorable geothermal areas, and this is an example also for the Adriatic sector, and to evaluate geothermal potential for electric power plant production. So the best geothermal area with temperature measured than 100 degrees are located mainly in Tuscany, in Latium region, and in the main islands, Sicily and Sardinia. In the volcanic islands of the Tyrrhenian Sea, we can see the orange dots in the southern part of the Tyrrhenian Sea, and in some sectors of the Po Valley, Peri-Adriatic Belt, and Bradanic Trench. The violet area represents the prospect area for unconventional geothermal systems. And for low, medium temperature resource, these areas are located in the area mentioned above, but also in many other areas. And UGI have estimated the theoretical geothermal potential of the medium-high temperature hydrothermal resource, and UGI have estimated a theoretical capacity of 1,200 electric megawatt. And for the unconventional geothermal resource, UGI have estimated an energy potential of about 200 electric gigawatt years. And this value corresponds to a capacity of some 4,000 electric megawatt, which is about 4 times higher than hydrothermal resources. So, bearing in time this info, INGV has tried to focus on an interesting area from a geothermal point of view, such as the volcanic islands, where we see these volcanoes in the light blue map, and where we see the violet areas in the southern part of Italy. And more or less in the COVID period, more or less 2 years ago, a brainstorming between INGV and the Energy Department of Sicily started with the aim to develop a geothermal project on Aeolian islands in southern Italy, in Sicily. Some consideration on Aeolian islands and in general on minor islands. Aeolian islands are minor islands. In Italy we have 27 minor islands. 20 of them are not connected to the national electric network. An example is the Aeolian Arc. And currently the energy demand is satisfied by small diesel power plants. And these energy solutions are really not sustainable for an environmental and economic point of view. I'm sorry. These minor islands have a huge renewable potential, sun, wind, and in some lucky cases has volcanic islands also in geothermal. And my question is, why don't you use this resource? So it is necessary to promote and plan energy systems that allow to increase the local energy production from renewable resources. And in the Mediterranean area, there are good examples of islands independent from an energy point of view, from solar and wind, and unfortunately only for this resource, but totally satisfied by renewables. And we must take example from this situation. And so INGV want to focus on volcanic islands. INGV know very well the Italian volcanoes and especially the volcanic islands. These are the active volcanoes in Italy and are monitored by INGV. From north to south we have on your right Colli Albani, Vesuvio, Campi Flegrei, Ischia, and then in that part, the Sicilian volcanoes, Etna, Stromboli, Vulcano, Pantelleria, and Lipari. And here we try briefly to explain the organization of the volcanic monitoring of INGV. The INGV has the main building in Rome, and we have other buildings in Italy. And volcanic monitoring is performed mainly by Roma, Naples, Catania, and Palermo in Sicily. And in particular, the Sicilian volcanoes are monitored by Catania and Palermo. The continuous monitoring is performed by Catania, seismological monitoring and the formation thermal monitoring. And the periodic monitoring, especially for geochemical monitoring, is performed by Palermo by sampling and analysis of selected fumaroles and selected thermal wells. Now some info, geological info about Aeolian islands. The Aeolian Arc is constituted by 7 islands. From west to east we have Alicudi, Filicudi, Salina, Lipari, Vulcano, Panarea, and Stromboli. These islands make a volcanic arc. And the Aeolian volcanoes are located between the southern Tyrrhenian Sea back arc basin and the Calabrian arc, Fourier arc region, the green part of the image. And these islands are formed around and inside the Marsili Basin. Marsili Basin is an expanding back arc basin characterized by thinned crust, 15 to 20 kilometers. And the volcanic products of the Aeolian islands have an age from 1.3 million years to the present time. Okay. The Aeolian volcanism is related to the post-collisional extension process in our collision zone. Usually, the Aeolian arc has been divided into 3 sectors. Respect to the Tindari-Letojanni fault, the TLF line. The active volcanism occurs along this fault and east of this tectonic line, and the compressive tectonic regime in the western sector inhibits uprising and eruption of magma. An exploration geothermal project was performed in Aeolian Islands between 15 and 18. And the first geothermal wells were drilled in Vulcano in 50s by INGV. And they reached relatively shallow depths, 235 meters. And then 2 more wells were drilled by joint venture Enel INGV. The first well is Isola Vulcano 1 was drilled between 1983 and 1984 and reached the maximum depth of 2,050 meters. And then Vulcano Porto 1 was drilled in 1987 and reached the maximum depth of 1,000 meters. And despite a high temperature, more 300 degrees at 1,815 meters. For the past technologies, the area was considered unproductive. The geothermal program was focused only on the volcano islands, but we think that there are good geothermal potential also in other Aeolian islands, such as Salina and especially in Lipari. And for this reason, between 80s and 19, some researchers have tried to evaluate the geothermal potential of the Aeolian Islands and especially on volcano islands. And from fumarolic activity has been estimated the thermal energy release and was estimated a value of 100 megawatt, thermal megawatt. And for this reason, and we want to investigate, to better investigate on Aeolian Islands, and recently, INGV and Regione Siciliana have signed a project, IRGE project, for the development of an inventory of the geothermal resources of Aeolian Islands. The project is just started in September 2022, and the project runs for 3 years. It's totally founded by Regione Siciliana. It is organized in 7 work pages. The first is dedicated to the management of the project, and then we have 6 technical projects with the aim to identify and evaluate the geothermal resources, the geothermal fluids, develop a reactive mass and heat numerical model, evaluate the geothermal potential, identify the best uses respect to the energy demand and the local activity, productive activity. Evaluate the geothermal resources also for direct and indirect use. And all this data will be collected in a public open web portal. And during the project, a strong dissemination activity will be done on site. And I'm concluding, just some lines from the last Sustainable Islands report, 2022. This is in Italian, but I try to translate. And they write, nevertheless, many minor islands have high renewable energy potential. Very few renewable power plants are installed. And in the minor islands, the percentage of energy demand satisfied by renewable source reached the nationwide lowest value, minor than 4%. And this is a form, a resumed form for the Aeolian Islands for energy demand, drinking water, mobility. And in the sector of energy, we can see the energy demand and the energy solution in this period is the small diesel power plants and renewable source solution. And it's indicated photovoltaic, wind with zero value, but it's a possible solution, but unfortunately the geothermal energy is not cited in this report. So I'm finished, and I hope this presentation has been interesting for you, and okay.
Thank you, Monia, for that presentation, and I believe we have really benefited on the information that you have given. If I can give a quick overview of the three presenters, kind of a small summary just to jog your mind so that you can prepare to comment or answer questions. Professor Carlo gave us an overview of the tectonic arrangements of this region in view of the presence of geothermal. And he did actually explain why geothermal is actually does exist in this region. Then the final bit was on the seismicity that is induced due to geothermal development. That gives some reason why some local communities are protesting against any development of geothermal in their areas. So maybe we as scientists see how we can explain this to local community to be able to buy in that there is need to develop, rather than just knowing a little bit. But we as scientists need to give good explanation that local people can actually understand and be able to accept the concept of geothermal development. Then secondly, Professor Bruno gave us an overview of the status of geothermal development in Europe, and in particular in Italy. And he did rank them, giving Italy as leading, Italy second, and followed by Iceland. And both, all the three countries, which are leading, of course, there are other smaller countries, like Germany and so on, they have more or less equal measures in terms of direct use and power generation. And he also mentioned about some challenges that exist. The number ones we know, and he mentioned about the social issues, sometimes political commitments, of course the finances there, technology, legislative framework, and so on. So he did actually point out some of the challenges, but he gave that good overview. Then finally, Monia gave an exploration of the exploration and results of geothermal exploration in this country, and she did correlate the volcanoes and the presence of geothermal areas and the manifestations. And then she made a case for some of the islands which are not connected to the national grid, that they do actually have potential for renewable energy which can be developed so that they can reduce the reliance on fossil fuels. She also mentioned finally on the Ionian Islands, where she's proposing that more work needs to be done. She also gave a good overview of the work which has already been done, historical work. And she also said about the power that has been estimated from those research, but she said that more needs to be done, and yeah, I think that's what I could get from what she said. So this juncture, maybe I welcome any comments or questions to the three panelists. Please identify yourself and to whom the question is referring to. Yes, Secretary, you can give the microphone.
Yes, thank you. I have a question for the last speaker. You mentioned that there are several examples of the Mediterranean area of islands in which the energy needs are completely satisfied with a renewable. Can you be more explicit about these examples? And by the way, is any of them considering geothermal? Thanks.
working?
It's not working, apparently.
Yes. Okay. In Mediterranean area, there are some islands in Greece and in Portugal, but all these islands are satisfied only by solar and wind. The geothermal energy is not, unfortunately, used, but are 100% satisfied by renewable resources.
So apparently there's no kind of motivation to move the geothermal because they're already satisfied with the renewables you are talking about. So I'm saying that since they're already satisfied with the renewable energy sources like solar, so it looks like there may be no incentive to ask them to move towards geothermal. Correct? Is that correct?
Yeah, also in Sicily, in the minor islands, in general in minor islands of Italy, among the renewables is never include the geothermal energies as potential solution to improve and increase the use of renewables and improve the energy supply, the independent energy supply of these minor islands.
Okay, thanks. But if they possess geothermal energy, then perhaps we could propose as researchers how the geothermal and the other renewables can be integrated. Say, because the other renewables like solar or wind could be intermittent. So, but geothermal is there continuously, so maybe we could propose to them and say maybe there's need to integrate the several technologies, including geothermal.
Yeah, this is a potential proposal to integrate the source.
Thank you so much, Sonia. Monia, sorry. Anyone else? Yeah, there's a hand here. Please go ahead.
My name is Tara Rogers. I am with the Clean Air Task Force, and my question is for Carlo, who presented on seismicity. I have a two-part question. Does your research extend into that higher temperature pressure zone, the brittle ductile zone? If it doesn't, do you intend to? And the second half is there an international consortium looking at seismicity with you?
Carlo, please. The second part of your question, please.
The second question was, do you work with an international consortium, other international groups, for example, the Japanese?
About this induced seismicity, you mean?
Yes.
Well,
You've got to come on.
Well, if I well understood, the first part of the question was related whether induced seismicity goes down to the brittle to tight transition in the deep crust, or I mean middle crust. Well, I would say not, because most of the induced seismicity is in the first, let's say, 5 to 7 kilometers maximum. Well, usually there is this cloud at the bottom of the wells, so it depends how deep is the well, and therefore the seismicity can propagate downward and maybe even down to 10 kilometers depth. At least that's what we observe in the US. The key issue is that there are different types of induced seismicity. That the message that I try to pass to you, and the rule I would say that is important to follow in order to not generate induced seismicity is not to modify the natural pressure, the fluid pressure into the reservoir. That's the main rule I see that is fundamental, both for oil and gas, but also specifically for geothermal exploitation. And whether, the last question is whether we cooperate, I would say yes. Well, with the INGV, we work with USGS and several other international agencies.
Thank you so much. Carlo, any other question? Yes, there's one here. Microphone, please.
I already talked. I have a question for Monia again and a comment. Do you plan, beside geothermal potential estimation, also to check for thermal storage? Because, and this is the part of the comment, sometimes also we discussed before, no? Wind, solar, so they are enough, but we already talked about intermittent source. And these so reflect my question on thermal storage, geothermal thermal storage. And also consider that, for example, in Sicily, when we work in Sicily, one of the questions in not only in urban areas, but also in many natural parks, Italy is full of natural parks, wind and solar plants are not allowed. But, for example, shallow geothermal plants can be used in those areas. So there are many things to be considered in establishing also the geothermal potential. One is the technical part, but there are also other factors, no, that should be taken into account in defining how much geothermal can be installed and for what use.
Ms. Monia?
We will try to estimate a theoretical geothermal potential, and we hope that the collaboration with the office of the Sicilian region and the office of the district of the Lipari and the head of the Lipari district can help to really translate the results of the project in real plans, and we think also the direct use could be in the small islands, such as the Eolian Islands, an important goal. Not only power production, but also the direct use for mainly for cooling during the summer period, when in the highlands come thousands of tourists.
Thank you, Monia. Any other? Please, Marit.
Hello. Juan Alvarez from Repsol here. I have a question for Monia. In your presentation, you mentioned that there were 2 wells drilled in the volcanic islands with high temperatures. But I was wondering if you have something to mention about permeability and if they found any fluid on those wells, and what will be the reservoir model for this volcanic island research. Thank you very much.
At the present time, we don't have a lot of data from these wells. I hope to have more data from ANIL and maybe from ANEL. And the fluids in these wells were, the problems in that time was that the fluids was intermittent, was not continuous in the reservoir. And this was the main problem for the companies. And for this reason, the geothermal project has not been continued in the 80s. But maybe we think that with the modern technology, we can have the solution, and we could use this high geothermal potential. And the geothermal exploration was performed only in Vulcano Island. but we think also in Lipari could be an interesting geothermal potential.
Thank you, Monia. Now, can we go to Marit, please?
Yeah, thank you. Let's talk money a little bit. I love the science, but let's talk the money. And Bruno, I think this question is for you because you mentioned the word investment. Now, the trend in geothermal is that the public investment goes a little bit down. It's not that bad because I think it is worthwhile to say that the private equity amount, as in the capital that's being invested in geothermal, is on the rise, and that is a good thing. So to talk about small island development states and take the Eolian Islands and Sicily, I think it will be fantastic to see one day these small power plants from geothermal to the islands. I hope Italy is ready. Because if I look worldwide where, for instance, the mining companies are exploring for, and especially Fortescue, for instance, to take the Australian one as a good example, they're scouting for high enthalpy, hot rock to do hydrogen. Green hydrogen. They're looking in Papua Guinea, they're looking in the Caribbean, they're looking in the Fiji Islands, and they may look here in Sicily. So Bruno, for you as UGI president, and maybe you can't speak on the entire Italian country, but is Italy ready for private equity to come in and maybe in a joint venture, but to work here in Italy and to work up those high enthalpy resources that apparently, according to the presentations, you have right under your feet throughout Italy, on the continent, but also on the islands?
That's a good question. I'll thank you for that. I mean, we are here, but not only we are here. There are a lot of, I would say, investors waiting and looking at that. Not only for, I would say, power production, but also for district heating, and also for, I would say, energy communities at local scale, you know, neighbors and cities and so on. But one of the main things, you know, stopping a deeper interest and a clearer signal for investment is having a national indication in terms of incentives, in terms of clear regulation, in terms of governance. There is not yet a mature enough environment for this. We are working for this. Several indicators and proxies are positive. Investors, there are several groups and investors ready to go and start, and new proposals have been put in terms of permit requests in different areas, not just in Tuscany, but also outside Tuscany, and that means that investors are there. The question about not only high enthalpy, but also mineral extraction from geothermal fluids, there is interest on that. But I would recognize in the institutional, I would say legislative, regulatory, and clear governance and clear politics in terms of renewable energies. From Europe, we have strong request and advice to proceed, but it's a homework of each country to start making it feasible and possible and realizing, you know, in reality, starting that. We are talking, communication needs to improve, legislation needs to be more focused, more clear, and the institutional environment. You know, we are changing now government. We are waiting this FAIR 2, which is the renewable energy sources incentives for the renewables which did not have enough attention so far, which is still there. More than 3 years to go, waiting for that. And the investors feel that there's something missing. Investors are there, but they need a strong sign. a strong sign from politics, from institutions, and we need the public institutions to work together with local administrations. And we are working on this. There are good signs and positive indications, and investments are waiting for that in several directions, but we need to push harder. Thank you.
I do agree with you, Bruno, that there's more we can do as scientists and researchers rather than just waiting. And we hear, for example, investors complaining that maybe, like in Africa, the process is a bit tedious, it's too long, or something like that. So I think we as researchers and scientists can come and really address those problems in our own ways. For example, it's a question of lobbying the politicians. I think we need to do more rather than waiting for the scientists, for the investors to come in and say, oh, the process is taking too long. If, for example, in Kenya, there is a requirement for the letter of commitment or something like that, then what do we do ourselves? How much information can we give to potential investors? And what is our role? Do we wait until the problem is actually at hand? So if we are able to foresee beforehand, if it's the social issues, what needs to be done? Do we wait until the investor comes to the ground and then he meets resistance from the people? What can we do in advance ourselves as a contribution to promoting that development geothermal, in trying to foresee the problems long beforehand?
Yes, thank you. And why not to attach to this discussion the point of the geothermal standard, the geothermal sustainability assessment protocol, which would like to have the stakeholders sitting around the table to look at the same problem to tackle and to address, and to talk the same language, and to try to reduce risks, to make applications, technology development, investment, research. That's another aspect. Europe is proposing and waiting for 10 million new geothermal heat pumps. A simple question: who's going to build them up? Who's going to design the new plants? Who's going to install the machines? Who's going to monitor and optimize the system? Because the underground cannot be projected and designed on a table. It's there. You need to make it working at the optimal stage, just adjusting your machines to the resource. And that requires time, cannot be designed in advance. Who's going to do that? We need to have them and the stakeholders around the table, and starting with this geothermal sustainability assessment process is just the key starting point. You need to have people sitting around the table at the same time to talk about the same problem. If you do not do that, then no way, because there is always an ingredient missing, and the cake does not come out with a hole in the middle.
Thank you, Bruno, for that. Any other question? Oh, there's one there. Okay.
Funziona. Okay. Good morning. It's Franco Caselli, an independent consultant and working for Geolog. My question is, in these days, we talk a lot about disconnecting the gas price to the electricity price. I think one of the problems in geothermal is that, we don't deal with a commodity, so we don't sell steam, but we sell electricity. Now, do you think disconnecting the gas price from the electricity, it will affect the economics of geothermal, especially in the near future? Personally, I think so. I would like to know your answer to that. Thank you.
It's addressed to Bruno. Is that correct? Okay. Any of you, please, panelists, did you get the question? Okay.
I'm not able to answer your question. I would like it to happen, but I'm not able to answer. I'm sorry.
Anyone? Anyone to add? Okay, it sounds like your question is complicated or doesn't have an answer. Okay, Carlo, do you want to attempt?
I just comment that it's an economic problem, and I think it's a fundamental issue, but it's not in our hands to have an answer at the moment.
Thank you.
In most of the country, it's been able to develop geothermal because there was some incentives. You know, Germany, in Europe, but even especially in Central America, South America. As soon as these incentives drop, even the exploration activity and production has some problem. So I think it's a question that we should analyze because, as I said, you know, we don't sell steam like you do in oil and gas, but you sell a final product which is an utility, which, you know, with the price is affected. It doesn't have usually the ups and downs that you have in the commodities, but it's much more sensitive to, you know, to the situation like is now. So honestly, I think you know, some problem it could create. I'm sure that a company like Enel is probably evaluating or considering this aspect.
Well, you are right. I think the main reason is why there is no a perception from the society of the importance that could be invested into the geothermal energy. So the environmental associations have communicated that only solar and wind are the good sustainable energy sources. There is the missing communication from our side. They don't receive the right information about the importance of the geothermal energy. I don't know if it's only their fault. Maybe it's also our fault, in which we did not communicate enough the relevance of geothermal power. I think the communication is a key issue in order to have the incentives.
Okay, thank you so much, Carlo, for that. Any other? I think it's 1 o'clock, and maybe I should hand over to Marit. Oh, thank you. Oh.
Thank you, Prof. Marita, for moderating this excellent session, and thank you to the three speakers who have given us so much insight into the Italian case study, but also with answering some fundamental questions, an outlook towards the future. So thank you all very much for your time. And with that, I'm closing session 2. Now it's 1 o'clock. Lunch will be served in the room where we also had the coffee. But before we go for lunch, I would really ask you to go for the group picture on the staircase, which is on the left-hand side. So go out of this room, go then to the left, and we will assemble everyone to get a full group picture. Thank you.